Okay, so one of the things that we're focusing this week is simplifying expressions so we can really get comfortable with variables and adding things together and multiplying things together when variables are involved. And so I'm going to review some of what I did last week with like the definition of an expression and that, and then kind of expand on it. So when we're simplifying expressions. So an expression is a collection of variables and constants, and they don't have inequality symbols like less than, greater than, less than or equal to, greater than or equal to, and don't have equal signs. So that's the difference between like an equation or inequality and an expression. So an expression doesn't have those symbols. And there's basically only two things that we can do to expressions. We can simplify or we can evaluate. So last week, I demonstrated how to evaluate expressions. This week, we're going to simplify expressions. So in order to simplify, we have to learn some more vocabulary. So we've got term. So basically, if you have a series of things and they're separated by plus or minus symbols, then those things in between the symbols are called terms. And the number in front of it is called a coefficient. I'm not really sure where that word comes from. And that's specifically if you have a number in front of a variable. So like 2x. 2 would be the coefficient.
Okay.
And then if you have something without variables, it's called a constant because it doesn't have a part that varies with it. So a simple example of an expression might be 2x plus 5 minus 10y. So we don't sign there, but we've got plus or minus signs. And we've got 3 terms. Now, when we're looking at the terms, it's a lot easier to look at them in terms of if you take any subtraction and change it to adding a negative, because when we define terms, we use the subtraction symbol as a negative when you're listing terms.
Okay.
So that's really important because a lot of people will put in like 10y as a term, but it's actually negative 10y. So any subtraction, rewrite it as adding a negative, and that can help you identify your terms. So we have 3 terms here. We have a term that's 2x, a term that's 5y, and then a term that's, or whoops, I put a y there. There was no y there. A term that's 5, and then a term that's negative 10y.
Okay.
And so the 2x and the negative 10y have coefficients of 2 and negative 10, and then 5 is a constant since it doesn't have that variable. So we've got 3 terms. 5 is a constant, and then negative 10 and 2 are our variables here, or variables, coefficients. So that vocabulary is really important because if you're asked on like a homework question or something, what's the coefficient, you need to understand what part it's talking about.
So I wouldn't say negative 10y is the coefficient, but I would just say negative 10?
That's correct.
Okay.
Yeah, so the variable part is not included in that coefficient. It's just the number.
Okay.
So we often talk about like terms where the word like is another word for similar. And so we're basically talking about similar terms. And we have specific requirements for for things to be called like terms. They have to have the same letters in them.
Okay.
So the same variables. And it has to have all of the same letters. So if they have more than one letter, all of those letters need to be present. And you need to have the same exponents on them. So If you have an x and then you have an x squared, those are not like terms because one has an exponent, one doesn't. So they have to match the variables and match in the exponents. And when we simplify those things, we call it as combining like terms, and we add or subtract the coefficients. And then the variable just kind of gets attached to it. Okay. So the variable hangs on. You don't really touch that part. You're just dealing with the numbers. So when we are simplifying expressions, we're still adding or subtracting. We just have this letter that hangs out, and we just have to make sure it hangs out with each thing.
Okay.
One way you can think about it as if somebody told you that you were at, way back in elementary school, you might say, if you have 1 apple and 2 apples, how many apples do you have? You have 3 apples. Think of apples as the variable. So if 1x and 2x, you now have 3x. So it's just kind of attached there. It's sort of like a label that can help you think about it. And sometimes for some people, saying these things out loud helps, because if you say out loud 1x plus 2x, it's like, oh, 3x. That's kind of versus if you look at it on paper.
Correct.
So reading these things out loud might help you kind of get used to adding these things. So when we simplify expressions, we need to know what the word simplify means. It's different from the word evaluate. So simplify means that you're basically trying to take something and make it as few terms as possible. If you can make it 1 term, that's awesome. Sometimes you can't, but you want to decrease the number of terms. And you do this using the order of operations because we still have numbers involved here. And you want to make sure that for it to be in simplest form, you have no parentheses. And if you have any fractions, the fractions are reduced. So when we have expressions, we've got these variables. It's very unlikely you're going to get 1 term. You usually have multiple terms because you may have different variables. You're generally going to have answers. Your answer will still have variables in it. It's not going to be just a single number like when we were doing the order of operations.
Okay.
But again, kind of think about it as a label. It's just kind of hanging out there. But you're still following those same rules of PEMDAS, basically. And so, we're going to start with very simple ones here where it's like 1-step problems. And then I will ramp up into the multi-step so you can really see the order of operations going on.
Okay.
So these are all 1-step problems. And I'm making sure that you see different variables because it's not always x, it can be anything else. So I've got 5k minus 10k. So this is literally, to simplify this, you literally do 5 minus 10. And so 5 minus 10 is -5. So our answer, I think I might have accidentally hit the black ink. That's not helpful. Is -5, and then the variable is k because it's just 5 minus 10. We have that k, it's just kind of hanging out. So this is basically a 1-step problem to simplify. Now, some people, yeah, go ahead.
Since it's 5k minus 10k, so you wouldn't do a -5k square?
No.
Okay.
So because it's like, if you think about it again as apples, 5 apples minus 10 apples, there's not really something as apples squared, So it stays, it just hangs out. We don't square it. Later on in this class, we will create things that are squared, and that's with multiplication.
Gotcha.
So multiplication is what creates the square. And if you think about it as terms of area, like length times width, if you have inches, or you have feet times feet, 2 feet by 5 feet, your units are feet squared for area. So the exponent comes about when we're multiplying, but not when we're adding or subtracting here.
Gotcha. Thank you.
Yep. And for people that might struggle with negatives here, I often recommend people turn all subtraction into negatives, so that way you can see that, okay, that's 5 plus -10. That's how you get that -5. Because especially when we start getting into more complicated problems, it will eliminate a lot of errors with signs if you get into this habit with some of the more complicated ones. So
Okay.
just, I would make that a good habit. And then, once you start getting more advanced algebra, you may not need to do that anymore, but it's good to get started and practice that from the beginning, because it will help a lot.
Okay, thank you.
So middle one here, I have -4p minus 2p. So to combine it, you're doing -4 minus 2. And, if you're struggling with those negatives, you can make that a -4p plus a -2p. And then that also makes it clear that you've got two terms here. So a -4 plus a -2, that is -6. And then our variable is p. So we just need to make sure that we write that there.
Mm-hmm.
And then on the one on the right here, I made them x squared specifically to show that, like, when we're adding, it still doesn't change. So we've got a -7x squared plus 14x squared. So you're doing -7 plus 14. Now, some people, because we can actually change the order that we add sometimes, it's easier for people to kind of reverse that and think of that as 14 plus a -7. So you can see that you're getting smaller because you're adding a negative. So it's really the same as 14 minus 7. So we get 7x squared here. And again, we don't add on the exponents or anything. It stays exactly as you see it. So it stays x squared.
Okay.
Now I'm going to throw in some multiple term problems here. So with different variables, and start getting a little more complicated so you can kind of see, what happens when it's more than just one step.
Okay.
So on the left here, we have 2y squared minus 5y squared minus 3y squared. So we have three things. These are all like terms because they all are y squared. And so we go from left to right when we are simplifying and you're combining things where you're subtracting or adding. We always go left to right.
Okay.
This kind of problem, I often see a lot of mistakes with signs. So I'm going to rewrite these all as adding negatives instead of subtraction, just to eliminate some of those errors.
Okay.
So we move from left to right. And so if it helps, you can like maybe underline to show that's what you're doing first. So we have a 2y squared plus -5y squared. So that's 2 plus -5. That gives us a -3. And then I have y squared. And then I still have that -3y squared. So that needs to drop down. So now these are still like terms. They're still all both y squared. So I have a -3 plus a -3. And that gives us -6. So our answer is -6y squared. Now, the middle one here, we've got 4 terms. And we've got things with variables and things without variables. So we don't want to just start adding left to right because we have to actually think about what am I allowed to add together. We have a 2ab and then a +5. That would be like as if I was adding apples and oranges. They're different. I can't count how many oranges I have if I'm also adding apples in it.
Okay.
So one thing that you can do is you can either like color code and kind of highlight or match things together. Like maybe I write the A, B stuff as one color, and then maybe the numbers as another color to kind of help you see what kind of matches together. So like everything with A, B matches together, everything that's just a number kind of matches together.
Okay.
Another thing that is helpful is to rearrange the order, because this is all adding. You can rearrange the order of adding with that commutative property. So I can flip around the 3AB and the 5. So that way I'm kind of lining up the things that go together so that you can see that those get added together.
Okay.
It's not necessary to write these steps, but they can help you visually.
Right.
So then when I'm adding, like I've got a 2AB plus a 3AB. So these are like terms because they both have A, they both have B, and they both don't have any exponents on them. So you're just literally adding the 2 plus the 3. They match after that. So that's 2 plus 3 is 5. So you have 5AB. And then I can do the other terms at the same time. So instead of doing like one addition at a time, like with the order of operations, once you identify what terms to go together, you can do those at the same time because they're not interacting with each other. Okay. So I could also do the 5 plus -2 at the same time, which is the same as 5 minus 2, so that is 3. So we've now simplified those, and now if I do the color coding like I've done here, we've got 2 different colors. We can't combine 2 different colors together because they're not like terms. One has an AB, one does not. So since we can't combine those, this is our final answer.
Okay.
So it's 5AB plus 3. It's considered simplified because it's still fewer terms than we started with. We started with 4 terms, now we have 2. So we were able to get it smaller. It's not as small as we might want, but it's smaller than it was. Now the third one here, again, we've got some more complicated variables. So I've got 8x cubed y plus 3 minus 7, then minus x cubed y. So I'm going to just start by turning all the minuses into adding negatives. And this is really important if we start to do the rearranging of these things. So if I like put my like terms together, when you rearrange, the sign goes with it. So that minus goes with it. And that's usually where people start losing negatives. So I have an x cubed y and then another thing with an x cubed y. So those are my like terms. And so I might want to rearrange those and put those first, just so that they're together. So that would be 8x cubed y plus, and if you have a negative and you don't have a number there, but you do have variables, you can always put a -1.
Okay.
So it's like there's assumed that that's a single thing. There's one x cubed y instead of 2 of them. We usually don't write the 1, but you can put it there to help you with your addition and your subtraction.
Okay.
And then I've got my 3 and my -7. Those are constant. Those numbers obviously go together. Like people see the numbers and they're like, oh yeah, I can add those together. It's usually the stuff with variables that get a little trickier.
Right.
So we add the x cubed y pieces together. So 8 plus -1, that's the same as 8 minus 1. So that's going to give us 7x cubed y. I accidentally changed colors there. And then we have 3 plus a -7. and that gives us a -4. And now, again, if you're doing color coding, you can see that these are not like terms, so they can't be combined. We have an x cubed y, and then we have something without it. So that's as simple as it goes.
Okay.
Are there any questions so far?
No, ma'am.
All right. I have tons of examples. Probably you're going to have more than enough. So now let's start ramping into doing some multiplication stuff. So order of operations, PEMDAS. So we're going to just always remember that, and remember that the multiplication and division is left to right, and the addition and subtraction is left to right. So those are sort of at the same level.
Mm-hmm.
So this was kind of going to be the basis of what we do. So P, the parentheses, you start by looking inside the parentheses to see if there's anything you can add together. Now, if I do my color coding with the variables in the parentheses, I've got a 2x on my first example here, and then I have a -4. Those are not like terms because they've got, one has a variable, one doesn't. So inside my parentheses here, there's nothing that I can do, so I basically skip that step. I have no exponents, so I skip the exponent step. So the next is the multiplication and the division. So we're going to distribute first. And the general rule is that we always distribute before we do anything else. That's usually the first thing you do when you're simplifying.
Okay.
So I like to draw little arrows, and I'm going to make sure that I'm writing down what I've got here. And actually, let me rewrite this whole thing with that subtraction is adding a negative first, just so that this makes it even more clear. Because then you'll see really why I'm writing these as adding a negative. So we're going to distribute. And so I have a -3 times 2x. And then you have a plus, and then you have -3 times -4. So the reason why I write that -4 as adding a negative is so you don't forget that negative sign when you do the multiplication.
Okay.
Because usually what will happen is that's where people lose a negative, is they'll do -3 times 4 instead of -4, and then they have the wrong sign, and then everything gets messed up after that.
Exactly.
And then because the +10 is outside of the parentheses, we don't multiply there. So we're still in the multiplication step. We still need to multiply. And when we multiply the numbers, because that's all we know how to do. We don't know really what you do with like a variable there. You're just multiplying the numbers. So I have a -3 times 2. So this will give me a -6x. And then a -3 times a -4 is a +12. And then I have +10. And once you've gotten rid of all of your multiplication, that's where you start identifying your like terms. So I'm going to use the colors again here. So -6x. And then I don't have anything else with an x, so that's just kind of by itself. And then I've got a 12 and a 10, and those are like terms that I can add together.
Correct.
So when I simplify this, oops, I accidentally hit the next slide. I've got a -6x, and then if I really want to get into the colors, I can leave the other stuff as white. And then I have 12 plus 10, which is 22. And then those are not like terms, because one has a variable, one doesn't. So that is our final simplified answer. So we're going to do the same thing with the one in the middle. I've got 5 minus 3, and then in parentheses, x minus 4. So again, any of the minuses I'm going to turn as adding a negative. So instead of 5 minus 3, that's going to be 5 plus negative 3. And then the x doesn't have a number in front of it. So if you have a variable without a number, you can always write a 1. So I'm going to turn that into a 1x. And then I'm going to add plus negative 4. And that just makes it a lot easier when you're doing the multiplication, because then you see what number you're multiplying it by.
Right.
I mean, the goal is by the end of this course, you can skip a lot of these steps that I'm showing here because you can do it in your head. Like the distributing, I can multiply that out in my head. But you're not going to want to skip that right now until you've had a lot of practice.
Oh, I know.
We don't want to get ahead of ourselves. So again, inside the parentheses, those are not like terms. So we're going to distribute first. So I'm going to be multiplying that negative 3 times the 1x. Now, one common mistake people do is if they don't rewrite it the way that I have, is they tend to do 5 minus 3 first, because that's the first thing that they see. But that's the wrong step. The wrong step is the multiplication. So I find that adding that plus in between there kind of helps you see that that's different. And it kind of adds a layer of separation. So I have my negative 3 times negative 1, and then I have my negative 3 times negative 4. And then I'm going to multiply those numbers out. So negative 3 times 1 gives me negative 3, and then I have my x. And then negative 3 times negative 4 is 12. So if I do my color coding again, I only have one term that has an x, just like in the previous example. And I do have 2 terms with constants, basically, that I can add together. So I don't usually do the rearranging. Like, I don't normally do the step where I write the negative 3x first and then do the rearranging. I will just kind of add those in my head, as long as you've got them kind of color coded so that you can see that. So we would have our negative 3x, because we just generally put the variable part first. There's no reason it has to be first. That's just convention. And then I can add my 5 plus 12, which gives me 17. And then those are not like terms. They can't be combined, so that's our final answer.
Okay.
Now, top right here, I, of course, had to throw one in with a fraction because we will see fractions throughout the course. So we actually don't have any minuses here that we have to rewrite. So we can go straight to the distributing. So I can just do the negative 1/3 times 6t. And because we've got a fraction, it's often helpful to write the 6 as 6 over 1. So that way you can see what you need to do for multiplying fractions. And then I always write my t's with a little curve at the bottom so that it doesn't look like a plus sign.
Gotcha.
Then I have that negative 1/3 again, and I'm multiplying it by 9, which again, because I'm multiplying by a whole number, it's helpful to rewrite the whole number as a fraction, because we have a fraction times a whole number, and then plus 10. So when we multiply fractions, you multiply straight across. So I will get -6/3t plus -9/3 plus 10. And then each of these fractions we would reduce, and these actually reduce out to whole numbers. So 6/3 is 2, because that's 6 divided by 3. So we get -2t plus, and then that, the -9/3 reduces to -3, and then we have plus 10. And now I can do my color coding. I have only one thing that has a t in it, and then 2 things without. So I have -2t because there's nothing to add it to, plus, and then -3 plus 10, that's the same as basically doing 10 minus 3, so that gives us 7.
Question.
Yes.
The negative, how did you get -2t?
6/3, that a fraction is the same as division. Yep.
Right, so that'll be a 2. Okay.
The one thing about algebra is you have to get good at looking at things and thinking about all the different things it means. Like 6/3 is a fraction, but that also means division. And so you need to kind of be able to switch between the two ways to look at it and decide, well, which is the best way to look at it in this situation. And here, doing it as division is helpful because it gives you a whole number.
Gotcha.
So there's a lot of different definitions and things that mean multiple things, and you have to kind of keep it all straight in your head. But if you can do that, that'll be very helpful.
Okay.
Any other questions?
Nope, that was it.
Okay. Now we're getting more complicated. Complicated enough that I've only got 2 of them on a slide now. I'm like, we're going to need some more space here. So, again, we're following the order of operations. And for most simplifying, the parentheses step and the exponent step, we just don't even look at because we don't have anything to do with them. Because there's generally nothing in parentheses that you can add, and we're not even dealing with exponents yet. I mean, we're not going to really square, we might square numbers, but certainly not with variables. So the first step is generally going to be doing that distributing. And I'm going to rewrite my minus sign as adding a negative so we can make sure that there's no mistakes there. Oops. So I don't really need to do anything with the first thing, the -3 times 2t plus 4w, but I do have that subtraction in the last term. So I'm going to add that as adding a -4w.
Okay.
And now when I distribute, I need to make sure that I'm only multiplying by things in the parenthesis. And I need to make sure that I don't start going too far. So I've got my -3 times 2t. And then -3 times 4w. And then I stop with the -3 because the parentheses stopped there.
Right.
And then I multiply the 8. So now I do the 8 times 2t. And then the 8 times -4w. So I can do those at the same time because those are considered 2 separate terms. So if we look at our original problem, this is considered one term because the -3 is not separated by the parentheses by a plus or minus, so those are all considered one term. And then this is considered 2 terms. So we have 2 terms, And we're temporarily making it 4 terms in order to simplify it further, because we don't consider it simplified if there's parentheses in there. So we have to briefly make it bigger and then recombine it. So I'm going to do all of this multiplication here. So I've got -3 times 2, so that's -6t. Then I have -3 times 4, so that's -12w. So you want to make sure you're writing down the right letter.
Right.
Then 8 times 2, so that's 16t. And then 8 times -4 is -32w. Now I'm just going to color code. So all of these have variables, but we have to make sure the letters are matching. Okay. So my -6t matches with the 16t because they both have t. And then -12w matches with the -32w.
Right.
So, oops. Sometimes when you have this many terms, it is actually very helpful to rewrite it so that you match them, just so that you don't get confused. Otherwise, what some people do is they'll like cross it out after they've added it together. And I'm going to just rearrange these right now just to make it a little bit easier.
Okay, that's what I just did.
Yeah. That way you can see, okay, so we're doing the -6t plus 16t. That gives us 10t. And then I have my plus. And then -12w plus -32w is -44w. And then these are not like terms because the letters are different. One's a T and one's a W. And we generally, when we're writing these in multiple variables, we will put them in alphabetical order. So that's why I put the T first, because T comes first in the alphabet. That's just a general rule. It doesn't matter because the order of addition doesn't matter, but it's just, you know, the convention that we use.
Right.
Now the second example here is very similar. So you'll see that the steps are all similar, but we've got a lot more subtractions here going on. So I'm going to first rewrite it. And any letter, any variable that doesn't have a number, I'm just going to put a 1 in front of it. So I'm going to make that a 1q. And then plus -5u. And now in the middle here, we have a minus, and then we have parentheses without a number. So that minus is going to be plus the negative, but we need a negative something, some number. And if there's no number and it's multiplied, we can put a 1. So if you're subtracting them, then you have parentheses. It's useful to put a -1 in front of there. So that way you know what you're actually multiplying by.
Gotcha.
That's also another spot where you could people accidentally lose a negative sign if they don't do that. So now I'm going to write all of my multiplications. And it's helpful to write them out and not try to do them in your head so early, just so that you don't accidentally like forget a variable or something like that.
Okay.
So I've got 2 times 1q and then 2 times the -5u. And then we have a -1 times 2q. And then we're going to do -1 times 8u. So that's all the distributive. We're still multiplying here. So we get 2q plus -10u plus -2q plus -8u. U. So everything with a Q matches, and everything with a U matches. So Q comes before U in the alphabet. I had to think about that for a bit. So we've got 2Q plus negative 2Q. Let's make that plus a white. Plus, and then we have negative 10U plus negative 8U. So our Q's 2Q plus negative 2. 2 plus negative 2 is 0. So those cancel out at all. And when you have a 0 Q is just 0. So you don't have to write 0Q. Let's actually just do that now. We'll write it first and then simplify it so you can see that would give us 0Q.
Okay. 0Q.
And then a negative 10 plus negative 8, that's negative 18U. And then the 0Q just is gone because that's basically 0 times Q, and 0 times anything is 0. Or it's like if you don't have it at all, there's 0 of them. So your final answer is just negative 18U.
Okay.
All right, I'm adding more things. Never ending, just going slowly more complicated here. So you're going to start getting into that. You do enough of these and you start getting into the habit of like, oh, we're always doing the first thing, the same thing over and over again. So we're going to turn all these subtractions into adding a negative. I'm going to write ones in front of any letters that don't have any numbers. So that's pretty much always going to be that first step.
I'm finding out my mistakes by doing this, though.
That's exactly why I recommend doing this. When you get good enough, you don't have to, but when you're just learning, it will save you a lot of heartache.
Yes, I see where my mistakes were at.
Yep. And they're usually involving the numbers or the signs.
You're right. You're definitely right.
Yep. Okay, so again, order of operations, PEMDAS, we're basically going to do all of our multiplication first. So I'm going to distribute here the negative 2 through the parentheses. Everything else, we just keep writing it down. We're not multiplying it by anything yet, or adding or anything like that.
Okay.
So I have a negative 2 times negative 3, then plus negative 6 plus 1n. And then I multiply my numbers, 7n plus negative 2 times 1, negative 2n. Negative 2 times negative 3 is 6. And we have plus negative 6, and then plus 1n. So gonna everything with an n as a like term. Everything without is not. And I know doing all the color coding and everything takes longer, but I think it's worth it because then it helps you keep everything clear.
True.
So I'm going to rearrange it so that all of my ends are first. So that just means that that one end in the back, I'm just kind of pulling up in the front. It's the only really thing that really has to move here. And so we have 3 things with n, and so we want to add those going left to right. You could add all 3 of them at the same time, but that's prone to making mistakes, so we'll just add the first 2 together first. So 7 plus -2 is 5, so that gives us 5n. Then we have our 1n that we still haven't added. And because the 6 and the -6 are a different color, they're different terms, I can add those together. 6 and -6 is 0. So if you want, you can write down that 0, but basically that's just going to disappear after this because they're gone. So then all we really have is 5n plus 1n, which gives us 6n. And so that's our answer.
Okay. Not so bad.
No. Slow and steady, one step at a time, and you can do it.
No rushing through it.
Yeah, definitely. You rush, you're going to make a mistake. So just take your time. It'll pay off. Better than having to redo the whole problem.
Right.
So on the right here, okay. So again, I'm going to rewrite all of my subtractions, add ones where I need them. So I have a few of those.
Okay.
And then we're going to do our multiplication, our distributing property. And we can do that in both terms because they're separated by pluses. So those can go on at the same time.
Okay.
And hopefully I have enough room here. This is going to get much bigger. I might have to write really small. I think I can do it.
Mm-hmm.
Barely made it in. Okay.
Okay. Yeah, it's very small.
Yeah, very small, but I got it in there.
Yes, you did.
So 6 times 1 is 6, so I have 6x plus, then 6 times 3 is 18 plus -12 plus -4 times 1 is -4x. -4 times -3 is 12. And don't be afraid to even just like what I'm doing right now, just say your math out loud. Sometimes that helps.
Yeah, it helps. It helps.
So everything with an x goes together. And then we have several things without x's. So I will rearrange and put my x stuff first. So we have 6x plus, and then -4x plus, and then my numbers, I've got 18, -12, and 12. Just make sure I've got plus signs in between there. And to make sure you haven't forgotten anything when you rearrange it, you could make sure they're lined up so they're still kind of
right.
I can see that they're lined up. You can even count. I had 6 things. I still have 6 things. That kind of helps you keep track here. Sometimes it's really helpful to use graph paper when you're doing math because that helps you line things up.
Okay.
So the x terms in yellow, 6 plus -4 is 2, so that's a 2x. And then with the numbers, we go left to right, we have 18 plus -12, so that's 18 minus 12, which is 6. Wait, yep. And then I'm going to have the plus 12. And then I can add 6 plus 12. So we still have our 2x, and then 6 plus 12 is 18. Now, once you start kind of getting used to all this, you can start doing things in a different order. Like I could have added the negative 12 and the 12 together first and then noticed that those cancel and I would have an 18. But that starts to get into advanced mental math and these little tricks. And I don't want you to try too many tricks too early. Not until you're ready.
No, not me.
Yeah.
Yeah. This is helping me though. This is definitely helping me.
Excellent. Now the next two, these are the last two I have. I'm throwing in the brackets because people get thrown off the brackets. So, and this was supposed
I need all the help I can get. This is helping.
That's supposed to be a negative 8 plus 3 here. Otherwise, it's going to be really big. Let me just rewrite this. I actually wrote 83 instead of 8 plus 3. That will make a big difference.
Uh-oh.
Yeah, because multiplying by 83, that would be giant. So let me write this neater.
8 plus 3. Is that 2x plus 4?
Yeah, 2x plus 4. And then we close the parenthesis, then we close the bracket, and then we have plus 10.
Okay.
So order of operations, we've got our parentheses here. A bracket is also considered a parenthesis. Normally you could write a bracket as a parenthesis, but then the parentheses start getting like lost because then all you have is parentheses everywhere. So that's why we use a bracket, just so that it's separated out. So we're basically simplifying. We work outside in, so we need to simplify the outside of the outer parentheses or brackets, so the brackets. And so then we look inside and we say, okay, now we need to follow the order of operations on the inside there. So we're working inside out. So the first thing we're going to do is that multiplication on the inside of the brackets.
Okay.
So in the beginning, I'm going to have a lot of things that I'm just rewriting and not doing anything with. But we start with that inside multiplication. So that 3 times the 2x, and then the 3 times the 4. Now, I think what the book does is when it gets rid of the inside parentheses, it turns the brackets into parentheses. It really doesn't matter. You can do that if you want, or you can leave them as brackets. Just in case, I've had questions where people are like, well, how did that suddenly become parentheses? And it's just like, well, we got rid of one set, so they wanted to make it look, people prefer parentheses, that's all. But it doesn't matter. I usually leave it as a bracket just so that it's consistent. So I need to multiply on the inside my 3 times 2x and then that 3 times 4. So we have our 6 plus 2, bracket, negative 8, plus 6x, plus 12, bracket, plus 10.
Yeah. Okay.
Now, on the inside, we're still simplifying basically inside. Now we're simplifying inside the brackets. So we're still following the order of operations. And we do have things that we can simplify here. We could wait to add like terms till the very end, but it will make things a little easier if we combine things now, because we have like this negative 8 and the 12 that we can combine.
Okay.
So I usually try to do that first, like inside, so that I just have fewer things there. So I'm going to have my 6x, and then negative 8 plus 12, it's the same as 12, but minus 8, so that's 4. And then plus 10. So this is all basically part of the parentheses step, where we're following the order of operations of the inside, and we're basically simplifying the inside brackets, and then we have to restart with our multiplication again and go through the process a second time to simplify the outside stuff. So we're still doing the order of operations. It's like a cycle where you simplify, go through the process till you're done, and then you start over as you start multiplying things out. So now we're going to multiply the 2 through the parentheses here. So I have 6 plus 2 times 6x, and then 2 times 4, then plus 10. So we have 6 plus 12x. 2 times 6 is 12. 2 times 4 is 8. Plus 10. Now I am running out of room because I don't have the luxury of So the 12x will go first. And now because I don't have more room, I'm going to add all 3 of my stuff together, the 6 plus the 8 plus the 10. And you can just put that on your calculator all in that row, 6 plus 8 plus 10.
Right.
And that will give me 24. And so that is our final answer. We get 12x plus 24.
Okay.
So it gets lengthy, but we can get there.
Yes, it does. Yes, it does.
That's the thing about algebra. Is like I've heard students complain that it takes so long, and it does. But you'll eventually get to the part where you can skip a lot of these steps, and then it doesn't take as long. So it's just a matter of the more you do it, the fewer steps you can write, and you start shortening and doing shortcuts and stuff like that. But we're just learning, so we're going to write down everything.
Right. All these steps will help me, though.
Yeah, exactly. Okay, last one. I've got lots of negatives and stuff in here, so I'm going to rewrite it. 1 plus negative 2 instead of the minus 2. Bracket 2, parenthesis, and then I'm going to write 1z plus 1. And I always write my z's with a line through the middle so that it doesn't look like a 2. So I just don't want to accidentally read it. Like I have my handwriting, and I have letters that I write differently just when I'm doing math. So I've got my letters and then my regular handwriting letters.
Gotcha.
So now the minus 5, we're going to make that plus a negative 5. And then I'm going to write a 1z and then plus negative 2 and then parenthesis and bracket. So everything in the brackets we need to simplify first. So that means I need to do the multiplication on the inside there first before I do anything else.
Okay.
So I've got 1 plus negative 2 bracket. Now 2 times 1z, then 2 times 1.
then plus, and then -5 times 1z, plus, and then the -5 times -2. Oh man, I'm really running out of room here. Okay, so if you run out of room, you can kind of go slightly under to kind of fit that in.
Right. Alrighty.
So once we've written all this, now we actually need to multiply those numbers. 1 plus -2 bracket. 2 times 1 is 2, so I have 2z plus 2 plus -5z plus 10. And then -5 times a -2. So my z's, those are all like terms. And then my 2 and my 10. So I'm still working inside the brackets trying to simplify there.
Right.
So I've got 1 plus -2 bracket, and then I'm going to add my 2z and my -5z. 2 plus -5, that's -3z. And then 2 plus 10, so we get 12. So now you can see color coding wise, we're done inside the brackets because those are different colors. So now we need to multiply the -2 through there. So I've got 1 plus -2 times -3z. And then plus -2 times 12. So that's 1 plus -2 times -3 is 6. So we have 6z. And then -2 times 12 is -24. So I've got just a single term with the z. And then I have the 1 and the -24 that I can combine there. So I get 6z plus, and then 1 plus -24 gives me -23. And there we go. We finished it off. And it looks like I lost you. So wait. And seems that I have lost you permanently. I must have internet issues. Okay, so for everybody that's watching the recording, lost Tina. So take these problems slow. You can definitely go through them step by step, and if you follow the order of operations, you will get to the end. And it's not too bad. You'll see as you do more practice.